Okay, so from my end, it's showing that I'm live. So can you guys just confirm whether I'm live or not? Just quickly confirm, okay? I'll just do a little bit of adjustment with my video. Okay, so this is me literally inverted. I think this looks good. Okay, I'll just do one thing. Hello, yeah, I'm audible, right? Just a minute, I'll just flip myself, or maybe this is okay. This is okay. This is actually okay. So how you guys doing, by the way? I'm coming live after a long time. Question. मतलब I didn't do question 2 actually. I was like doing the question 3 basically. Okay. I was doing question 3. I forgot the shortcut for pinning. It was something else. Just a minute. How tools shortcut for pinning window. Ah. Oh yeah, power toys, right? Press Windows Control T. Okay. Windows Control T. Actually, like I forgot like how to pin my chat and my camera, everything like that. Okay, so I forgot that. So it will take a little bit of time for me. Yeah, now it is done. Okay, so nothing is obstructing it, right? Okay, this is not getting obstructed, and I will also fix this. I think this is also not getting obstructed. Okay, so I'm perfectly audible, right? Just guys, just confirm me quickly that whether I'm perfectly audible or not. Okay. So I'm using a different device for writing. Okay. So yeah. So I hope this will be a good experience. So anyways, hello everyone. Let's start with our first question. Yeah, audible. Okay. The first question, it was very simple, but still I'll just explain you quickly. You are given two integers n and t. Return the smallest number greater than or equal to n such that the product of its digits is divisible by t. Okay. So this is a very simple thing. I'll just go to Excalidraw and I'll just explain you guys. Okay. So what was it though? Just a minute. There was n and t, right? So let's say uh, they've got n, okay, and t. So see, when I'm writing, I'm not looking at the screen of my own laptop. So yeah, it may happen that I may miss some of it because uh, now like I'm not writing with my keyboard. I mean mouse and keyboard. Okay, so yeah. So let's say I've got n and t, and what I have to do is I can add a few. I can add 1 to n a few number of times so that it becomes divisible by t. Okay. So basically, this is what I have done in the code. Nothing more than this. I'm adding 1 continuously to t, and we have to find it whatever is the smallest number. Okay. So what I do is basically, so let me just erase this. Okay. Was third one a double binary search? The third one was sweep line. Okay. I started like from after the first one, I went to the third one because I thought that I maybe be able to do it, but I'll just explain it. You don't need to worry, okay? Just wait. I'll explain the second and the third one, like both I will explain simultaneously, okay? Now let's say what I have done is basically in this the first problem, that is if n mod t it is equal to 0, then I can return directly n. Otherwise, I can continue doing it n plus plus, okay? Sorry, this is not n actually. That was the product of n, okay? The product of all the digits of n. So now you can check the sorry, yeah, this one. So yeah, this is a product. Okay, this is a function for having the product, and this is the function that we have to do. So if product of while product of n not t not equals to 0, we have to make it equal to 0, so you can add it. Okay, so I hope this is clear, right? If this is clear, just write in the chat quickly b. Okay, rather b and c, because I will be explaining b and c together. B is this and c is this. I'll be explaining the solution of this guy. Okay, the lip sutar. I'm audible, right? Because I can't pull out my stream thing. Actually, that is the problem. Yeah, it shows me I'm perfectly audible. And encoding overloaded. Consider turning down video settings or using a faster video. Oh, okay, I get it. I'm having a video encoding issue, basically. So that is the reason why this thing net sucks. Okay, let's do one thing. So this guy is still leading it. Okay, so I think this is the best explanation that I can give you guys. Okay, so let's go to B. Maximum frequency of an element after performing operations part 1, and this is the part 2, and both the codes are having the same answer. Okay, so just understand what the question is basically, because that is more important at this moment. You're given an integer array called nums, and you're given two integers k and nums operations. Okay, you must perform. Okay, should I just increase the size of the screen though? Yeah. So you must perform an operation nums operation times on the nums, where in each operation you select an index I that was not selected in any other previous operation, and an integer in the range minus k to nums I. Okay, return the maximum possible frequency of any element in nums after performing the operation. The frequency of an element, you will know that what it is. Okay, so basically let's go over here. Sorry, right? Yeah. So let's say we have got 1, 4, and 3. Okay. Now since we have got 1, 4, and 3, now let's say for our better understanding, we are going to sort it out. Okay. So let's say if I'm sorting it out, we can remove this and it becomes 1, 3, and 4. Okay. Now after it becomes 1, 3, and 4, what we can do is we can like add some of the numbers. I mean we can subtract 2 from some of the numbers. We can add some 2 to some of the numbers. I, we can add k to some of the numbers, or we can subtract k from some of the numbers. Okay, not 2. So that is the main goal of our whole thing, right? The main goal. Can you take a bigger example like 5 to 6 elements? Yeah, we can take it. I think I have one of such cases in. No, I don't think I have. But I had it. Okay, do one thing. You give me an example. Okay, you give me an example. I think I forgot to fix the latency of my stream. So that is the reason the this thing is lagging, right? The chats are lagging, I guess. I forgot to maintain the right latency. I'll do one thing. Okay, 14553. 1 4. Oh, sorry. 5 5 3. Everything is visible, right? Yeah, 1.553. And you are telling that k is equal to 2 and nums operation is answer should be 4 here. Okay, I'll just do it. Okay, I'll just do it. Nums operation 2. Now 5 and 5. So first of all, just for your understanding, we are not going to use that because in the in this question the constants were like it is everything is 10 to the power 9. Okay, and only nums of length is 10 to the 5. So what we can do is we can maximum sort it out. Okay, sort the whole thing. Nothing else we can do. So anyways, I'll just show you by sorting it out because that becomes easier. Okay, so I can sort it out and it becomes 1 3 4 5 5, right? Now since we have got two operations and we can have two to it, so what I can do is I can add 2 to this and add 1 to this, right? That is what you're going to have, and that's the reason like all of these numbers are going to be 5. That means the maximum frequency is 5. 4. That is for the number 5. Okay, so now let's do one thing. Now I'll just explain you my logic, not my logic actually, this guy's logic. Okay, so I don't know how many of you have gone across this algorithm called line sweep algorithm. Okay, sweep line algorithm. I don't know. How many of you know about this line sweep algorithm though? Just a minute. I think I'll just go for a poll just to check. Tell me. Nah, right? So it's 100%. Okay, someone voted that he knows line sweep. Do one thing. Whoever knows line sweep, just give me a gist because that's not a like big issue of a problem. Just give me a gist of what you think it is. It's already using binary. Yeah, you can solve it using binary search. Even I was doing it, but mm, yeah, you can solve it. Let me do one thing. I'll just explain you the binary search algorithm first, okay? And then I'll go to the line switch. Okay. So, like, notice this very carefully. Okay. So we have got this. Okay. Now let's see what we can do is for every specific position. Okay. For every specific position, we are going to check. You used binary search. No, I don't think I can do it with binary search because I was stuck on it for a long time. You just do one thing, you just write exactly, even I am thinking so. You just do one thing, you just write it in the like, you just give me the link of your solution so that I can go through your solution because I don't think binary search is a possible algorithm for you. Okay, so what basically line sweep means is, okay, so let's say you have a axis, okay, let's say the x axis or the y axis. So basically over here we have an axis, and for the axis what we can do is this number is, let's say, x minus k, and this number is x plus k. You get it? So basically that is the range that x can vary from, right? So any number that is after this, that is x plus k plus 1, any number that is after this, we know one thing very surely for that, that this part is not valid for it, right? That part, that this part, I'll just use the laser, this part, okay, This part is not valid for it. Is it clear? Is this thing clear? Just tell me quickly if this thing is clear or not. Well, the binary solution will give TLE for the third one. Oh, okay, okay. I think I got an idea of what you're talking about. I think I got an idea. Leave it. I can't copy the solution for this. Anyways, so just look at this. I don't know what the heck is wrong with this Excalibur, because I'm using collaborative thing over here because I'm using a separate device for the writing of that, a separate touchscreen device. Now look at this code, okay? Look at this code. It tells that I'm having just understand this code, okay? Or rather, what I'll do is, should I explain it first? Let me do one thing. I'll just explain this, okay? Now let's come to Excalibur, okay? I'll just explain you this quickly. Let's in our solution, what I'm going to explain, you're going to have three things, okay? Three things. One is a map. Oh, sorry. One is a map, okay? The other one is a hash. Okay? Other one is a hash. Not clear, please repeat. Yeah, I think I'll just explain you this and then I'll like go through the code, okay? You don't need to worry much about it. I'm having a hash and then I'm having points. Okay. For the time being, you don't need to focus on points. Okay. These points are not important. For the time being. Like you will get it why we are using points. Points are just used to optimize the whole thing. Okay. It's not a main thing. So what I'm storing in map is the frequency of the elements that are there in nums. Okay. So what is the map having? It is having the frequency of nums of I. Clear? So it is having the frequency of nums of I. What is the hash having? It is also having the frequency, but it is having the frequency of nums of I minus k. Okay, as well as nums of I plus k plus 1. Now you may ask me that why k plus 1? Okay, but there is something funny about this, that is it's not going to store both their frequencies uniquely. Okay, so for every specific element, what it is going to do is it is going to add whenever it finds this, it is going to add it to it, I mean add this to it. Okay, and for this he's going to subtract it. You get it? Like this is, I am not getting the logic of this. Do you get like what I'm talking about, what the map is doing and what the hash is doing? The hash is basically adding numbers of I minus k and deleting numbers of I plus k plus 1. Now I'll just go to the thing that why it is doing so. Okay, Now look at this very carefully. Soumya, this is specifically for Soumya because I'm going to explain it. Okay, I'll just delete this, or let me keep it for now. It's okay. So Soumya, just look at this. Okay, so let's say we have a number line. Okay, in this number line, I'm at a position, and what is, like if this thing is x, what do we know about it? So I think I'm also having a lag from my side. But okay, so let's say this thing is x, this point is x. Okay, so we also know one thing, that x can, what is the minimum thing that x can become? It is x minus k. And what is the maximum thing that it can become? It is x plus k. So what we can do is, we can choose this whole thing. I'll just change the color. We can choose this whole thing. Okay, but anything that comes after this, it is not in our range. And even anything that comes before this, that is also not in our range, right? So now since we are going from the smallest to the x minus k to x plus, exactly. Now since we are going from the smallest to the largest thing, so now there's something more interesting that comes into our point of view. That is the fact that, where was I? I was talking about x minus k, x plus k, still hash. Okay, so now see this. Okay, now if we are going to add something to it, like if we are going to check whatever, what we do in sweep line or line sweep is basically, we are going to check like whatever is satisfying for us. Okay, whatever is satisfying for us. So now whenever since we are going from left to right, that is from the smallest to the largest in a sequential manner, so we have to consider this range. Okay, what color should I use? I think I'm okay. So we have to consider this range and exclude, okay, and exclude this range, because we are not going to focus on this range. Okay, this range we are not going to focus on because we are going from the smallest to the largest. So this thing we don't need to focus on for now. Okay. Oops, 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 oops. Okay, so this thing we don't need to focus on for now. It's okay. Now how we are going to focus on this? Now for every specific point, we are going to just manage the starting point. So we sort and start then. See, since you're having hash maps and maps over there, I mean not hash maps, you're having maps, so you don't need to sort it also. Okay, so that is the point where the points, I told you in the beginning initially that the points you can ignore for now. So that is the point where the points comes. Okay, that also like removes the sorting for you. That is what it does basically. So you don't need to worry much about it. Okay, for now, just think it like this, that don't worry about the sorting thing, just think it like you got it right. I think you got it. Okay, so now what we do in line sweep is basically we just look for the starting points of every specific interval. Now look at this very carefully, that since we know, I'll just use the blue color only, since we know that this is the starting point and this is its ending point, and we are not going to be focused on the starting point, right? Sorry, the ending point, right? So basically we are going to be focused on the starting point. Now since, bro, great, I too thought of that initially, later changed my, okay. But what we have to do is we have to just focus on the starting point. Now since we are doing this, since we are taking this into consideration, this thing, this range, okay, so we have to by default take off this. Okay, sorry, I think it's not visible for you guys. I'll just draw it again. So what we have to do is we have to take off this range. Okay, do you get it? This blue range. Now since we have to add this range, That is, since we have to add where's the laser? Since we have to add this range and take off this range, now comes the most important thing, that how we are going to handle it. What we basically do over here is we add this. Okay, this thing we add, and this thing we subtract. So what is the beginning point of the next range? It is nums of I plus k plus 1. Plus k is the last point that it can reach. That is what Soumya told us, x plus k, right? So x plus k is the last point that it can reach. So anything after that is the starting point of the next specific thing, and we are not going to consider that. So don't think about this, that this blue thing that I marked, this blue thing, this means that just the next interval. It means that everything after that. So we are not going to consider everything after that. So that is the reason we are going to mark the starting point of that. And what we do is basically exactly. Now I think this thing will make some little bit of sense. This hash, okay, that is frequency of n of I minus k, and this thing we are adding, okay, this is the present place that we are at, and this thing we are taking off. I'll just use this thing, and this thing we are taking off. Okay, this we are adding, and this thing we are taking off. So is it clear, like what we are doing? The algorithm is very like complex. You don't need to understand it for now. It's not complex actually, it's easy only, but you don't need to understand it, because that's none of like that you don't need to understand it simply. So I hope this part is clear, right? I'm pretty sure that this part is clear. Now look at the solution. Okay, I'm having a map MP, I'm having an unordered map hash, I'm also having a set called points. The set called points, don't look at it for now, don't look at it, just understand what the map and hash are doing. Okay, so for the hash, what I was doing, I was storing the frequency of the present positions. Okay, I mean present elements, not position, present elements. So I'm just adding it. For the remaining part, what we are doing for the MP, I told you that is IT minus K and IT plus K plus 1. This thing is also clear because I was explaining you this for such a long time. Now what do we do for the points? Now see, since points is a set, it means that if I'm going to have some duplicate elements into the points, it is going to ignore them. So basically what we insert in points is IT minus K and IT plus K plus 1. That is all the elements in this. Okay, all the elements that are accessible, we are going to add it in the points. Why do we do it? Remember that sets are like just throwing the non-duplicate elements. Okay, it ignores the duplicate elements. So that is the reason we are optimizing it. So in spite of going for all the points from 1 to, what was it, 1 to 10 to the power 5, we are not going to, not even 10 to the power 5, it is 10 to the power 9, right? 1 to 10 to the power 9, because that is what all the points are. So we are not going to traverse from 1 to 10 to the power 9, because that is going to give us a TLE, right? Understand it? In spite of doing that, we are going to go from all the points. We are going to go through all the points, because that are the only points that we need to access. The other ones we don't need to access, right? Now initially answer is 1, because we know that if there is at least one element, so the frequency of that element will be 1. So initially, no matter whatever it is, the answer is 1. Now we go for a sum. Okay, now the sum is very interesting. The sum is basically the prefix. Think it like this: the prefix till map, the prefix of map till IT. Okay, so what is IT? IT is the points, and I am storing the MP of IT into the sum. Okay, and then what I'm doing is, if whatever, this is the answer. Okay, this is the answer. Let's say this is what we are finding basically. So if the answer what we are finding, it is minimum than answer, we know that we don't need to consider that. Okay, So we are going to consider only if it is maximum. So this part is very clear, I think. If you are doing CP and you don't understand this part, just this part, answer is equal to maximum of answer comma this, then it's like you're not doing CP that good. Anyway, so after that what we do is we are going to take hash of IT. Why do we take hash of IT? Because if we are at a position, let's say, and we have to find out like how many things, how many elements can we have at that specific position. Okay, so let's say for the example that we had earlier, okay, I'm going to go to the example that we had earlier. I'm over here, right? Okay, so I think Soumya gave us a very good example. That was 14553. Okay, 14553. So this was the example that Soumya gave us. The 3 is not proper. Now it is okay. This was the example that Soumya gave us. Now look at this, okay? We are not sorting it, but we are automatically it gets automatically sorted. Why? Because we are using points. Okay. Now look at it how the sweep line thing works. So let me have MP, and what was the other thing? It was hash, right? Yeah, it was hash. Now for hash, what happens? Hash is just storing the frequency of all the elements. So for hash 1 has got frequency 1, 3 has got frequency 1, 4 has got frequency 1, and 5 has got frequency 2. So this is what hash is doing. We don't need to focus on hash for now. But for the remaining things, for this 1, if we are going for 1 minus k, hi. So if you are going for 1 minus k, part छोड़ के बाकी समझ आ गया what is basically points are doing. Okay, you don't get the point. That's the this contest, I think it was tough. Points was very easy, man. Like what it meant. Actually, I think you didn't get it. Okay, see, where was I? Okay, funny face. Hmm. Now notice this, okay, very clearly. We are putting the IT value into hash. We are putting the IT minus k value into map. We are putting the IT plus k plus 1 value into map. Okay. So what are the points that we are accessing? These 3 are the points that we are accessing, right? This IT minus k, and this IT plus k plus 1. Okay, this thing. So at a later point when we are going to like process the whole thing, as I was telling you that we are not going to sort the thing, but whatever operation we are going to do, it is in a sorted manner only. Okay, now since we are going to access these points, so we don't need to access all the points. Like if you think about it literally, if I move this IT points, and in spite of this, if I write int IT is equal to 0, and nice first question explanation, you can like rewind the video. Exactly that's what I'm talking about. Okay, so now this is clear, right, Soumya? So that is what we are doing. Okay, now let's talk about this. Okay, so now we are going to go a little bit up and just focusing on the map part. Okay, I'll again write it, what the example that Soumya gave us, 14553 553, sorry, 14553. Now what the map will look like is the main thing. Okay, we are not more focused on the hash anymore. We are now focused on the map, MP. Now for this one, so what is the range of this one? What was the value of k that Soumya gave us? K was 2. Okay, and the number of operations was also 2, if I'm not wrong. The number of operations was also 2. Okay. Now think about it, like since k is 2, so for this specific one, I'll just use this color. For this specific one, we can have 1 minus 2, that is minus 1, and 1 plus 2, that is 3. So this is the range that it can have. And anything after this, okay, anything after this, that is from 4 to infinity, it is not in our case. So for the map at minus 1, we add 1. And for 4, we subtract 1. Clear? I know the concept. If they give some hint, I can solve the contest for that didn't come for 2 and 3 questions. I think this contest was difficult. You don't need to worry much about it. There will be a lot of concepts that will not be that you won't be understanding, but it's okay. Okay. Now we got for 1. Okay. Now let's go for 3. Or let's say we are not going to go for 3. Like we are not going to sort it. Okay. We are going to go sequentially only. Let's we go for 4. Now for 4, it is going to be 4 minus 2, that is 2, and 4 plus 2, that is 6. And what is the next range? It is 7. So for 2, I'm going to have, what to say? I'm going to have a 1, and for 7, I'm going to have minus 1. Then for 5, thanks, yes, thanks. So for 5, what is it? It is going to be 3, 7, and 8, infinity. This was also infinity. Okay. So basically, 3 is now 1, and 8 is minus 1. Now since we have 5, so in spite of writing as 1 and minus 1, we are going to write it as 2 and minus 2, because basically we do it 2 times. Okay. Now we have got 3. So basically for 3, what happens is we have 1 and 5. Okay. 1 and 5. Now since we have 1 and 5, so 1 becomes minus 1 and 5 becomes 1. Right? This part is clear. So the points are clear, I guess. Okay. So I'll just do one thing. I'll just encircle the points. So what are the points that we had? Now that is the most important thing. Okay. Let me do one thing. Let me just make it a little bit smaller. Okay. Now look at what are the points that we had. We had these points, right? And we had these points, like these points. Okay. We have these points and these points. Now that is what the points are doing. Okay. Now what is the points? Now in points, automatically it becomes sorted. So let's say what are the points? The points are minus 1, 1, 2, 3, 4, 5, 6 was there. No, 6 is not there. 7 is there. 8 is there. Okay. So these are the points. Clear. Now we are going to do this operation for every specific point. What was the operation? Hash of it plus minimum of sum minus hash of it. Common nums operation. Now this nums operation is just to check that whether we are permitted to do this number of operations or not. Because it may happen that we can like make it, but the minimum number of operations is not satisfying us. In that case, we have to do this. Okay. Now what sum is? Sum is basically the prefix sum of all the um, MP values. Okay. Now let's go to Excalibur. So let me do one thing. Let me write the values of MP for everything and then also the values of hash. Okay. So for the MP, I'm writing it in red. So the values of MP for this is 1. For 1, it is minus 1. For 2, it is 1. For 3, it is 2. For 4, it is minus 1. For 5, it is 1. For 7, it is minus 1. And for 8, it is minus 2. And this I am writing as blue for the map. I mean not the map, MP, not the MP, for the hash, that is 1 3 4 5. So everything has 1. Okay? 1 3 4 5. Okay. Now look at the thing. Okay. Now since we are like adding the MP, okay. So when we are at -1, what was the formula? Hash of IT plus minimum of sum minus hash of IT. Okay. Why do we take hash of IT? Because we know that if a element is like if we have a frequency of this for a specific position, a specific element, then that is the minimum that we can have, right? And then we can like take out some other elements and try to make it equal to that element. Okay. So basically hash of IT is what is already that value, what is already having that value. And what is sum minus hash of IT? That is what are the other things that I can have in that value. Okay. So if I'm trying to make like -1, so what are the other things that I can make -1? It is 1, right? It is that value. Do you get like how this thing works? I think you get it, right? So this thing works like this. So that is -1. Now if we are at 1, so now we know that this thing, I'll just use a different color so that you can understand it better. So now you know that this one is already there, right? This one is already there. So this is going to contribute 1. And for the other positions that we had earlier, okay, that we had earlier, now that is going to have an effect on us on this. That is 1 minus 1. What is the value of like the whole thing? It is 1 minus 1. That is what is the sum till that position for the red part. Okay, focus on this red part only. So 1 minus 1 is 0. Okay, so sum minus 1, that is -1, right? So whatever is minimum, that is sum minus hash of IT. Okay. So sum minus hash of IT is -1. And what was hash of IT? That was 1. So 1 minus -1, that is 0 only. So till this position, nothing is going to be considered. Okay, because obviously it is very much clear. But now what I'm going to do is I'm going to go directly to 5, because I know one thing, that I can explain you one by one, like going from here to here, and I can explain you this. Just a minute. So what I can do is I can explain you. Okay, it's not a big deal to explain you, but I will be not considering 1 2 1 1 2 3 4. I'm not going to consider. I'm just going to consider 5 for now, because I know one thing, that for the most optimal solution there will be 4 elements that will be 5. That is this 4 5 5 3, right? Now look at this. Okay, I made a mistake. I think I made a mistake. That is the value of this. This will be 2, right? It was not 1. You can see that it was 2. It was not 1. My mistake. Now for 5, what happens? What is hash of IT over here? It is 2, right? Now look at this. Okay, let me do one thing. Let me just delete this part. Why isn't it getting deleted? It doesn't get deleted. Just a minute, huh? Now it is deleted. Okay, I just erased it out. Now look at this. Okay, now look at this very carefully. So for, I'm just going to consider for 5. Okay, for 5, this is 2, and this 1 is not our main thing, because whenever we are going to consider the red thing, that is the MP, we are going to consider the prefix sum, right? So what is the prefix sum? That is 1 minus 1, that is 0, then plus 1 1, plus 2 3, minus 1 2, plus 1 3. Okay, So what is the value now? It is 3. So what should we do? We are going to consider 2 for sure. 2 is considered every time because like there are 2 5s in it. So if we want to make 5, so 2 will be already considered. Okay. And then after that, so what was the value that we had after adding all of them? 1 minus 1, 0, 0 plus 1 plus 2 minus 1 plus 1. What was it? Sorry, I forgot. 1 minus 1, 0, 0 plus 1, 1, 3, 2, 3. Right? It is 3 right now. It is 3 right now. Now look at this very carefully. Okay. Now since he told me that we can have the value is 2. Okay. We can have the value as 2. Do I have a copy of the numbers? I think I deleted the only copy of the numbers that I had. Just a minute, I'll just go. Now see, for 1, 4, 5, 5, 3, right? So this 3 can go to 5, this 4 can go to 5. Now what was this? It was 2 basically, right? Now since we are going to check for 2, okay, since we are going to check for 2, so basically this 3 and 2, okay, this thing, if we look at it carefully, now since we are going like point by point, the points that we were inserting, I think we have made a little bit of mistake, but like the thing works, but I don't remember where I made a mistake. So it will be 2 basically, and this 2 plus 2 it becomes 4. Okay, this thing will be 2, and this thing, the sum of all the elements before this will also be 2. Okay, but I made a mistake. I think I don't know where. Okay. Okay, I think I made a mistake in the fact that I sorted the whole thing. It won't be sorted completely. Okay, it won't be completely sorted. The sorting will be done at a like different basics. So, but anyways, it will be 2, and this from this 2 we can get 2, and from the remaining thing we can get 2. Okay, so is that part clear with you guys? I think the last part I kind of messed it up, but like this solution works. Okay, you can say simply one thing, that this solution works because this is the line sweep algorithm. Okay, it works. What I can do is just to check what would be the order, I'll use the example that Soumya gave us. It was why do I have such a bad memory? 14553, 14553, and then 2 and 2, right? No, it is perfectly sorted only. Minus 1, 1, 2, 3, 4, 5, 6, 7, 8. Minus 1, 1, 2, 3, 4, 5. Okay, there was a 6 there. Did I miss a 6 out there? Yeah, that should no that yeah, there should be a 6 because 3 plus 2 is 5, and yeah, there should be a 6. I messed up a 6. So that was the reason why I was having an issue. So anyways, I think this is clear, right? This is clear. I messed up a 6. So what I'll do is I'll go to the next part of the video. I mean for the next solution, okay? This thing I haven't done. Look, I'll be very much honest, I haven't done this question. So what I'll do is I'll directly go to the discuss base where to pack the necessary digits, scan for longest prefix, recursive digit dp. Okay, we can have a recursive thing for this. Yeah, okay, okay. Is this providing me with a recursive thing? Just do let me just do one thing. I'll just read the question. Okay, I haven't read the question for this. The smallest divisible digit product 2. You're given you're given a string num which represents a positive integer and an integer t. Okay, done. A number is called zero free if none of its digits are zero. Okay, done also. Return a string representing the smallest zero free number greater than or equal to number such that the product of its digits is divisible by 2 if no such. Okay, just return -1. Okay, so this is a case where it is returning -1, that is having 26 in it. Can anyone tell me why it is returning -1? Like, I know that obviously because there is no possible thing, but do you have any idea like why so? Why is it not having any possible thing? So for that you have to look at this, okay, very carefully. I know, I know, I know. Now see, let's look at the number 26 very carefully, okay? How can we factorize this 26? This 26 can be factorized as 2 and 13, right? It can't be factorized more than this. Cannot imagine this. Okay, so it can't be factorized more than this, right? Now this 13, that is the like largest number that comes in as factor. This largest number is a 2-digit number, so it can't be a 1-digit number, right? So we should know one thing very clearly, that if the number, if the number that we are checking for its divisibility is having its largest factor as a 2-digit number, I mean not the factor, largest prime factor as a 2-digit number, so in that case we can see directly one thing, that it is not possible. Because if we want to make something divisible by 26, we have to make it divisible by 13, right? And if we want to make something divisible by 13, so it should be a multiple of 13. And what we are doing is we are just multiplying all the digits of a number in this case, right? So we can't form 13 or a multiple of 13 by just multiplying the digits of a number. Is this clear? Is this thing clear? Now since, because I haven't done the question, so I can't like tell you something that like this is, you're going to do it like this, you're going to do it like this, because I'm also solely depending on the discuss, but there are only 2 solutions out there in the discuss and none of them are upvoted. So I don't know which one to follow. I'll just follow Sandeep, this guy's. Answer exists if all prime factors of t are in. Okay. The first thing is that it is a 1-digit number. Okay. Log 2 of, so adding 47 new digits will always give answer. Use digit TP to satisfy prime exponents. Okay. Got it. This is like, you know what, like if in this question, this criteria that the number should be greater than we have to find the next largest number after num. If this criteria was missing, this was not given, this would be a very simple question. How so? What you can do is you can factorize this whole thing, this this whole thing, and whatever would be the digits, you can write it one by one. Like even if they gave that this number is equal to 0, then also we can do it. Okay, how can we do it? We can just write the factors, make the prime factorization, and simply go on writing the digits one by one. So let's say if we had give me a number, give me a number, give me a number, give me a good number actually. I'll just think of a good number to make you understand this. Let's say if we had 36, okay, and we have to make the number that is divisible by 36. So now if I go on factorizing it, so it becomes 2, 18, 2, 9, and 3, 3, right? So if I write all these digits 1 by 1, that is 2, 2, 3, 3. Satisfies, right? It satisfies. So that is the most important thing. Okay, so first of all, what you have to do is what I feel. Okay, I haven't gone through this solution. I can code it also though. Okay, this is a very tough solution. He's using cache like he's just flexing his Python skills. Even I have been coding in Python for the past few days. Okay, I think this is a better solution. This is a better solution. Okay, because we like see what he has done is I'm not sure what he has done though, but what I feel that he has done is I'll just tell you. We know that since all the prime factors should be in the range from 0 to 9, so what are the prime factors that are in the range from 0 to 9? It is what are the prime factors in the range from 0 to 9? Should I be considering 1 though? Is he considering 1? That is not a prime factor. No, he's not considering. It's just considered 2, 3, 5, 7. Okay. So let's say we are having 2 is a prime factor, 3 is a prime factor, 4 is not a prime factor. I mean prime number, sorry. 5 and 7. Any other number apart from these 4 are not a prime number from the range from 0 to 9. Because we know one thing, that all the digits, like not all the digits, like we have to make the digits as these only. Okay. Just to have that number. So what we took an example of 36. Okay. So we had 2 2s and 2 3s. Okay. For 36. If we multiply them, it becomes 36. So in our final answer, what we can have, we can either have 2 into 2 and make it 4. Right? We can have 3 into 3 and make it 9. Works, right? Or we can have 2 into 3 and make it 6. Because any other thing, like if you try multiplying 2, 2 and 3, it is exceeding the one digit limit, right? So we can't have it. Okay, so this part is I think clear. That is the reason why he's using 237. Now definition of smallest number, this is the function only. So while not t mod p, so what he is doing, he's just checking for all the numbers and he's checking whether that prime factor is a prime, I mean whether the prime number is a prime factor of nums or not. Okay, so while not t mod p, c of p plus plus, and t by is equal to p. Okay, t by is equal to p. If t not equal to 1, return minus 1. What is this? This is the basic thing that we have done. That is, if the after prime factor in the whole number, we find that any one of its prime factor is not in this range, that is 2, 3, 5, 7, then we can directly say no. For this part, I don't think this is a complex thing. This is a very simple thing. This is what I was explaining. That is, for this 2, 3, 5, 7, what you can do is you can directly say that it's not possible. Just return minus 1. This is a minus 1 case. Okay. Now the difficult part is this case. And what he has done is he has done for all the numbers. So 2, 3, 4, 5, 6, 7, 8, 9. Why is taking out 1 and 0 from here? Because we know that it has to be a non-zero thing. And we also know one more thing, that if it is 1, it's not going to hamper your whole thing, because anything multiplied by 1 is 1 only. So now he is going to check what is the minimum requirement of that element of C in that. Okay. So 8 comma mod. This is actually tough. I'll prefer not explaining this. Okay. Because if I start explaining this, then it's tough. Okay. What he's done, I'll just explain you what he has done. I won't explain you what you have to do. He's just taking, like, for every specific element 1, 2, 3, 4, and he is just taking like what is the minimum number of that element that you need. Okay, but that is complex. That is complex. See over here, what he has done is, if not mod 2 is equal to 4 equal to 0. if mod equal to 1, 2, 2, 4, 1, 0. Okay, else 2, 4, 0, 1. What does it mean? You get it? What it means? So what it basically means is, I'll just tell you. So if not mod, that means if the number, let's say, think like this, if the number is odd, okay, if the number is odd, so in that case we know that we won't have a 2 in its prime factor. Now since we don't have a 2 in its prime factor, we won't even have a 4 in its prime factor. Clear? Else if mod is equal to 1, okay, in that case we know that we are going to have a 2. But why don't we have a 4? Because let's say it is having only one time 2 dividing it. After 2 divides it, it is a odd number. So in that case we won't be having 4. But if it is more than once 2 divides it, then we are going to have a 4. Okay, so that is what he is basically doing over here. The same thing goes for 3 and 6 also. But when there is 3 and 6, then 2 and 3 should also be considered, because if there is a 6, you won't be having 2, you won't be having 3, because you're just merging this 2 and 3 together to make it 6. That is if 2 and 3. If both 2 and 3 is there, he's just going to omit the 2 and 3 and going to consider only the 6. Okay, and one thing is very simple. If he's having 8, he knows that it is very simple. He can have 2 to the power 3. Question 2 and 3 sucks, and question 4 is like, I won't say anything about it. Okay, and see, 9 is basically 3 to the power 2, right? So that is how he's managing the 8 and 9. This is how he is managing the 2, 4. This is how he's managing 2, 3 and 6. I mean 3 and 6. So basically we are managing, 1 is not needed to manage, 2 we are managing, 3 we are managing, 4 we are managing, 5 we haven't managed yet, 6 we are managing, 8 we are managing, right? 5 we haven't managed. So how is he going to manage 5? He is going to manage 5 normally. He is going to have it C of 5. And for 7 also C of 7. Why so? Because if you don't need to manage anything, because that is a prime number, right? 5 and 7 are the prime numbers, and they are not going to hamper anything. If you do 5 into 2, it is 10. That is a 2-digit number. If you do 7 into 2, that is 14. So they are just very free elements. Okay, they are free. So he doesn't need to manage them. But the other elements he needs to manage basically. And then he's going for checking what is the minimum requirement of C, and then he does this. Okay, this thing you don't have to understand for now. But this is a very complex thing. The fourth question was complex. So do you guys think that it was too complex? The contest was too complex for today? %40 people know sweep, 60% said that they don't know sweep, and there were 10 votes. Okay? 51 minutes and 10 votes, not bad. I haven't seen like how many people are watching the video though. It feels like I'm coming live after such a long time that I forgot like what I used to do in my life. You should do CP marathon, like 2 hours streams for CP. I can, but only if the contests are unrated. Right? If the contest is rated, I won't do that. Okay, so now 3 people are watching this. One is Soumya, one is Christian, and one is me from my device. Okay, so I'm lagging a lot. I just realized I'm lagging a lot. But it's okay. Let's do one thing. Let's just try doing this. I'll just read the question. If it's too hard, I will just leave it, okay? Because tomorrow I'll be working on the weekly contest. I'll be giving that also. So given 20 years and an x, you have to construct an array of positive numbers where for every this thing, nums of I plus 1 is the number and the result of the bitwise and operation between all the elements of this x. Okay, interesting. The bitwise and of all the elements is x. The solving contest, yeah, I can do it. I can do it. But since I am not much into CP recently, okay, I'm not much into CP recently. That's it. You think this is easy? How come this is so easy for you? Why do you think this is easy though? Like I know a solution for this. I just came like just came in my mind. Possible solution for this can be like we since we know the x, so what we can do is if x we can just take the binary version of the x, and for like for all the ones that are there in x we can have them in the array, okay, one by one. Like let's say if we are having 101, so we can have 1, we can have 100, and then we can have 101. Okay, so that is the thing. And after that just like have all the elements after 14 or something like that. Okay, so basically what we can do is we can I'll not write the whole thing. Find one. Let's do it because I am too stressed by doing such hard problems. So let's say we have got 0 1s initially, while n mod 2, if n mod 2, sorry, while not n mod 2, it's going to be while n, if n mod 2 1s plus plus n by is equal to 2. And what are the numbers that should be before that? If I'm having two numbers, two ones, there can be two possible numbers, three possible numbers. Okay, I get it. Okay, this is it. And if x is, I actually needed a long end, so is equal to n. We'll return n. Otherwise, we'll return n plus something, right? Just do OR with the next number. I don't get it. I'll try this. If it doesn't work, then I'll leave it. Basically, okay. I won't look into it anymore. This question. First let me do this question. If it works, then only I'll like explain the intuition. I think I made a mistake over here. Answer would be x basically. This everything will be x. That is the possible thing. So it can be maximum of this x plus what is possible basically. Whether possible is better, uh, n is more. So possible. What is the error? No matching function for max. Eh? Oh, okay. My mistake. No, see, like I don't know whether this is the answer or not. Right? Even I have to check whether this is the answer or not. This is a possible answer that I think of. So for 3, 4, 1, it is 6. It is 7. Oh, it is wrong answer. It is wrong answer. I messed it up. Sorry. How can it is? Oh, okay. No, sorry. X should be answer. Hmm. How many ones are there in 4? There is only one 1 in 4, right? That means that the length of this can be 1, but the length of this should be 3. So 3 minus 1 is 2. 3 minus. Oh, okay, there is 1, right? 1, 1, that is. Oh, possible minus 1. Oh, plus 1. Sorry, possible plus 1. Sorry. Possible plus 1. Answer equal to answer plus 1 or x. This is the answer. Okay. Answer plus 1 or x. How come this is the answer? From 1 to n. Did I read the question right though? If it is and, it means that 0, 0 cancels out. I mean 0 and 1 makes it 0. Answer plus 1 or x. Oh, okay. Okay, I get it. The first element is 7 only, right? The first element is x. So if the first element is x, so the next element should be something in which, like, the positions of which it's 1, it should be 1, but the other positions will be varying. So that is the reason from. I get it. Now I get it. Now I get it. Yeah, you're right. I was thinking it in a different way. Okay, I was thinking differently. That is from 1 till n. What we do is we are going to check what is the next element that is having all of them as 1 apart from one at one position, right? Yeah, so that is answer plus 1. Yeah, I get it. I get it. Leave it. Let's leave it for now. Let's do one thing. Let's just rate the problems quickly. Okay. I'll just do one thing. I'll just rate the problems real quickly. intuition was in order to make the next least compared to current rightmost revert to exactly that is what I was talking about. Like if we are having oh oh I think I'll be having a problem like if I write it from this. Okay, I'll just do one thing. I'll just write it from here. So yeah, I get it. Like let's say if we are having 1001, so what we can do is we can only change like these things will be fixed. The ones will be fixed, and we are going to only change the zeros. Right? That is what the main intuition was. I get it. So basically, there is also another intuition for this. You know what? You can get the what to say? You can get the binary of n minus one. Okay, you can get the binary of n minus one, and then for all the positions, okay, for all the positions that are having zero, you can replace it with that binary. That also works. I think that will be a better solution because it is going to be done in log of n, and the maximum of log of n, comma uh, log of x. So basically, the maximum of log of x comma n. I mean, log of maximum of x comma n. So that will be a better solution. So I think you can do it in log of maximum of x comma n. Okay. So this is. Do you get it? Like what I am talking about? Anyways, leave it. I think I'll just read the whole all the problems. This is easy. Okay, I usually have more than this, right? Okay, this is easy. This is medium. This is hard. This is very hard. Or rather, I just rename it as impossible. This is impossible. This is something between easy and this. Like this is what it is. Okay. If you're talking about A was easy, undoubtedly. B, no, B you can do it with binary search also, right? So yeah, B is over here. B and C is over here, and D is over here. Okay, so that's it from my side. Contests are unrated, right? So yeah, B is over here. B and C is over here, and D. Okay, so that's it from my side. So unrated, right? Yeah. Bye.